Hey guys, what's up? My name is Gabe, and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine in Java series. Now, in this episode, what we're going to be doing is covering 3D picking. What is 3D picking? It's simply clicking on an object in your screen and returning that you clicked that object. So, in the case of a 3D world, it could be more complicated. You could have 3D objects like some tree, and the tree is coming towards the camera, but it's also going away from the camera. And if you click on this branch right here, it will return that you clicked this tree. But if you also click this branch over here, it still returns that you clicked this tree. Now, we of course have a 2D context, so we'll only have 2D objects, but we want the same idea to apply. Where if you have an object here, you click on it, and it returns that you clicked object of ID blah, 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 wherever that is the object's ID. So if that was 0, 1, 2, 3, it would return 0. Now, how do you do this? The first approach, which I thought of and implemented and realized was garbage, was it's not garbage, but it's just not the best solution. You can have bounding boxes, right? So if your objects are squares, you just put a square around it, then you run a physics calculation every time the user clicks. And you go through your physics world and your game object and all that stuff, and you return which boundary the mouse clicked between. But what happens if you have something like this? You have a donut, then you have a character whose leg just so happens to go through there, and then his other leg goes through there. And what if our user clicks right here? They're not expecting to get this donut whose bounding box is going to look something like this. Well, it'd probably be a circle if it was any good, but they're not expecting it to hit this donut. They're expecting it to hit the player behind the donut. And if we click here, we're not expecting to hit the player, we're expecting to hit the donut. And so this calls for a better solution. This solution will also work with arbitrarily complex objects without any hit in performance too, because think about it, if you have an object shaped like this, doing a physics detection to check and see if it was exactly inside or outside this object is very difficult. But we don't need to do physics. Instead, what we can use is 3D picking. Now this is basically just coloring our image according to the IDs of our objects. So what that means is basically we color the background and we color it some color that's like, oh, this is our -1 color. It just means that there's nothing here. Then for each object we would color them according to their ID. So this one would be color 1. He'd be 1s everywhere where his pixels take up. He would be 0 everywhere his pixels take up. He would be 2, and he would be 3, just every single place. And then this guy, say he was object 4, would have 4s for every single pixel he took up. Now, is there any way that we could potentially figure out how to color every single pixel according to an object that's occupying that space? It turns out there is. It's this thing called shaders, right? We know what shaders are. We know how they basically just color something according to an object. We know we're using a batched render which patches in a bunch of data to the GPU to color each pixel on the screen. Now all we have to do is say, hey, let's do 2 passes over our game world. The first pass is going to be invisible. We'll color a window of the same size as our game world, except what we'll do is we'll color it with object IDs. Then the second pass is our render phase. Inside the render phase, we actually render everything to the screen. It's really that simple. We'll just create an invisible texture that we query every time the user clicks, and we look up the pixel they clicked on, and then look it up inside of this texture that we render to that's invisible, and then it returns us the ID because it's literally just the pixel color. And then we render again so that they can actually see their game world, and we just render the appropriate colors. Now, there's a lot that we have to do in order to get this all to work correctly, so this tutorial is going to be a little bit longer, and I apologize in advance for that, but I think it is well worth it. Now, how exactly do we accomplish this, though? Before we actually go in and start coding, I do want to briefly go over how this will work. And we'll use frame buffers, right? We used a frame buffer before, and we're using it to basically render our scene to an invisible picture that we then display to the user later on, resized, right? That's how we're putting it onto our IMGUI window. Well, we'll just create another frame buffer, except this frame buffer will say we're going to have a special shader, which basically just colors IDs. Then we'll render to this frame buffer using this special shader, and we know that we can grab the texture from a frame buffer pretty easily. And so if we can grab the texture from a frame buffer, GL gives us a few functions called GL read pixels, and we can basically just query this function. And this function will say, hey, give me an XY position on the texture you want to look up. I'll return it to you in some array. And then GL read pixels returns us the pixel that we just read from this frame buffer. And now we've got the pixel. that we just clicked on. With this very brief introduction, let's go in and start coding it and actually see how all this works. Now, let's just remind ourselves of where we left off in the last video. If you remember from the last video, we basically made it so that the screen coordinates are being picked up properly again, and we can calculate like the mouse coordinates inside of the game viewport according to world coordinates. That's basically what we did. Now, let's go and start to do this by going into our render package, and we will create a new class called picking texture. And this is basically going to be the picking frame buffer, picking texture, all that stuff just wrapped into one class. Now, I'm going to admit this is not the best way to go about this, and there are definitely better ways. Particularly, I don't like how this is tied directly to the engine. When are you ever going to need to tell what object ID a user is clicking on when you're not in the editor? If you know what I'm saying. Like, I think this should be an engine editor specific feature. This should not be part of the actual engine, and yet here we are putting it with the actual engine because we don't really have a separation of engine and editor. So there's a lot of different things you could do to make this better, which I have done in my actual game engine that I'm coding, but we'll leave it as this just so that we can see how it all works. Now, for this picking texture, we're going to need a few different things. We're going to take in a integer. This is going to be the picking texture ID. So this is going to be like the actual texture ID. Then we're going to say private int. This is the frame buffer object. So that's the FBO ID. And then we're going to say int depth texture. And this may not even be necessary, but if you do want to do 3D stuff, this will be necessary. I'll talk about that a bit more once we actually go about creating this. And then we're going to go ahead and say public picking texture, not texture. And we're going to take in an int, a width, and an int, a height. So this is the width and the height you would like to make this picking texture, which will be the same size as your game window. So in my case, that's 3840 by 2160. In your case, it could be 1920 by 1080. It's basically just going to be the same size as your frame buffer. Then we're going to say if not init, width and height. And then we will assert false and say error initializing frame buffer. Well, actually, picking texture. That's a little bit better. And then we'll just go from there. Now, what is this init method? This init method basically just initializes our texture. So we'll take in a width and a height in here. And this will basically create everything that we need. And this should return a Boolean to let us know whether it succeeded in creating the frame buffer object or not. So this is going to be very similar to when we did our actual frame buffer. It's going to look a lot like this. So much, in fact, that I think I'm just going to copy all this and then we'll tweak it to work for this. And once again, another thing we could do to make this better is instead of copying this code, we can make like a factory, which I want to do in the future, that creates frame buffers with different options. And so that would be a better way to do something like this, but we don't have that option right now. Instead of creating an actual texture here too, I'm just going to remove this line. We're not actually going to create a texture. We are just going to create the texture ID ourselves and everything. So we'll go ahead and do this part manually. So right here is where we would usually create the texture to render the data to, as it says there. But what we're going to do is say GL bind texture, and we'll say GL texture 2D. And we're going to say we're going to use the picking texture ID. And then we're going to go ahead and basically do everything that we would do in the texture now, except we're going to add a few more things. You see how we have like the text parameter I and all that stuff. We're basically just going to redo all that in here, except explicitly say everything. So first we're going to say text parameter I, and we're going to say GL texture 2D. GL texture wrap S is GL repeat. So if it wraps in the X direction, we just want it to repeat the texture. And then we'll do the same thing for the T, which is the Y direction. And then I'm going to go ahead and copy that. And we'll say GL texture mag filter. And we're going to say this is GL nearest. So if we are stretching the picture, we want it to choose the nearest pixel. This is important. We want it to pixelate. We don't want it to blur because we're storing IDs in this picture. We're not showing anyone this picture, so we want it to store the most accurate information, not blended information, which is what would happen if we chose the other option for this, which is GL linear, I believe. Okay, and then we'll just do the same thing for the GL texture min filter, and we will also do nearest for that. Then we'll text the image, so we'll upload an empty image to OpenGL so that our GPU has image in store that it can use. So we'll just say GL texture 2D. It's level 0, so it's 0 in terms of MIP map levels. And then we're going to say GL RGB 32F. And so basically we're saying we're storing RGB data of size 32 float. This is important because we're using a float in Java, which is of size 32 bits, which is 4 bytes. So very important that we get all this right, otherwise you will get weird errors. And we're going to say we're going to pass in the width and the height. That's how big we want it to be. A 0 border, and that's basically like if you had a border around your image or something. We don't. Then we'll say it's of type RGB, so RGB data is what we're passing in, and we are passing in a GL float, and then we will pass in 0 for the pixels because we don't actually have any pixel data. We just want it to create some empty space so that we can use it. Then we're going to go ahead and say GL frame buffer texture 2D, and we will pass it not this dot texture to get ID, but we will pass it this dot picking texture ID. So basically we just created the ID here, and then we went ahead and did everything as it would normally be done. And we never actually did create that. So we should also make sure we initialize this by saying picking texture ID equals glgen textures. And that will make sure that we actually generate a texture ID that we can use. Okay, so this creates a 2D image that we will store on the GPU, and this is where we'll actually write our ID information to. Then we're going to create one more thing. We're going to go down here and say create the texture object for the depth buffer. And once again, I don't actually think this is necessary, but we'll create it just in case. And so basically we're just going to create a depth buffer object so that if one sprite is behind the other, it should get rendered appropriately, and we should get the appropriate Z coordinate because of this. So we'll just say depth texture equals glgen textures. And then we will say GL bind texture, GL texture 2D, and we want to bind the depth texture. Then we will say GL text image 2D. So we'll just skip all the parameters. We don't really care about parameters since this is a depth texture. And we'll just pass in GL texture 2D. It's a 0 bitmap level, and we're going to say this is a depth component. And we're going to give it the width and the height. And we're going to say 0 border. We're going to say this is of type GL depth component once again. And the actual type is a GL float, and 0 for the pixels because we don't actually have any pixels we're uploading. And then we'll just say GL frame buffer texture 2D once again, and we'll say GL frame buffer. We're attaching a depth attachment this time. And we want to use texture 2D. It's just a 2D texture. And then we give it the depth texture. So we give it the actual ID that it can use. And of course, we have to put in that mandatory 0 for level for no reason. I'll actually go down here and just indent that so you guys can see that. Okay, so we basically just attach the color attachment, which is our actual texture we'll be rendering to our frame buffer. Then we attach a depth texture, which I don't think we did. It's just a depth attachment, so it stores like the Z index of each of our pixels, which may not even matter really, because I think the way we're rendering this doesn't really matter. But better safe than sorry. Now, instead of doing this RBO, we don't really care about a render buffer for this because we just want the frame buffer. So we're going to say disable the reading real quick. That way everything works okay. So for older GPUs. And we'll say GL read buffer is GL none. So basically this says right now we're not reading from any frame buffer. Don't read from a frame buffer. Then we're going to say GL draw buffer is GL attachment 0. Oh, and that's color attachment. Color attachment 0. So that's where we want to draw to, right? So we're saying, okay, now we want you to draw to GL color attachment 0 every time we call draw for this. Then we want to make sure that the frame buffer completed successfully. And then we want to restore, unbind the texture and frame buffer. So then we'll just add in a call to GL bind texture, and we'll say GL texture 2D 0. So we'll just unbind the texture, and then we unbind the frame buffer as well. That way any subsequent calls won't accidentally get problems. And we'll say return true down here if we make it to the bottom, and return false, which really doesn't matter because this assertion will break out of our code for us. But in case you're in like production mode or something, these assertions will be removed. So then you would want it to return before it tried to do anything else. Now we're going to need a few more functions for this picking texture. We're going to make an enable writing, which basically means we're binding the frame buffer. That's literally all this is. And we sort of do it with our actual frame buffer too. And we'll basically just say bind the frame buffer for drawing, and we're going to give it our frame buffer ID. Then we'll say public void disable writing does the opposite of this, which is just copy paste this. And then we just want to bind 0 because we're binding nothing. And that way we don't actually write to this frame buffer. Then we want this last one, read pixel, which takes in an integer x, integer y. Now this is like, give me whatever the pixel at xy on this texture is. And so we'll say GL bind frame buffer, GL read frame buffer, FBO. So we're saying bind the frame buffer. We're going to read from it. We're not drawing to it. We're reading from it this time. And so that the GPU puts it in a special mode that basically says, hey, we're about to read from this, so get it prepared and everything. Then we'll say GL read buffer, GL color attachment 0. So we're saying we're also reading from the 0th color attachment, which is where you'll remember we're drawing everything to. So we're reading from where we're drawing from, which makes sense because that's where all our texture ID will be stored. Then we'll say float pixels equals new float 3. So we stored RGB data. We're going to read RGB data. And then we'll say GL read pixels X, Y, and we're going to say the height is 1 by 1. So if we actually take a look at these parameters, it says int X, int Y, width and height. So like how many pixels is the width and height, and then the XY is like what pixel location you start from. So we're only reading 1 by 1 area of pixels because we only want to read 1 pixel. This is basically what we're doing here. And then we'll say the format is RGB because that's what we uploaded it as. Then we'll say the type is a floating point number because that's the type of RGB data that we sent. And then we want to give it the pixels so that it knows to put whatever it reads into this float array. Then we can simply return int pixels 0. And this is actually going to give us the wrong result, but we'll see why in a moment. Okay, so that was complicated. Now, how do we go about the rest of this? Well, we still have a few more things to do. Let's go into our window and actually start using this. So I'm going to hit Control N and then just type in window, and we're going to be taken to the window class. Let's go to the top of it. Right below where we have the frame buffer, we'll put in a picking texture. And this is just going to be our picking texture. And once again, I don't like the way this works too. Ideally, you would make this work in a much better way. But we're just trying to get the concept down right now. So we'll go into here and then we'll say this dot picking texture equals a new picking texture. And we'll give it the same size as our frame buffer. So I'm going to give it the exact same size because we want to make sure that we're mimicking our game world exactly. Otherwise, this won't work right, because if these aren't the same sizes, then our IDs are going to be in different locations than what we're seeing visually in our actual frame buffer, right? So we make them the same size. That way we get the same result that we would expect. Then we're going to basically do 2 passes, right? So right here, we basically loop through and we say, okay, let's bind our frame buffer, and then we draw everything to our frame buffer, and then we draw IMGUI. So we're sort of doing 2 passes here, but we're not passing over our scene. And in order to do this too, we actually have to update our scene a little bit, because right now, updates our scene and renders it, but we want to split that up into 2 completely separate components because we just want to render. We don't want to do the update. We don't want to accidentally update our logic twice. We just want to render twice. So we'll add a new abstract method in here called abstract void render. And then inside of our level editor scene, we'll go right below where we have the update method, and we'll just make a new method, which is the render method. And so I'm going to delete that, rename this render, and then we'll move this down into the render method. So we'll just say this.current scene, or this.render. And this way we just sort of separate it into 2 phases so that we can control when we're updating and control when we're rendering. Now we'll have to go into level editor scene and override it as well, just so that we get rid of the error messages. So I'll just do that. If you had any other scenes, you would also do it there too. But that should do that. Now we can go back into our window and do 2 explicit rendering passes. First, to make sure we didn't break anything, I'm going to call render here, and we should get the exact same output that we've been getting. And we should get no errors from that texture. Everything looks okay. So I'll go into here. And right before we begin the debug drawing frame, we're going to do our render pass 1, render to picking texture. And then I'll just render pass 2, render actual game. So this is our first render pass. We'll render to the texture. Then we will render the actual game, which is, of course, what's happening. So we'll go up here, we'll say GL disable, GL blend. Once again, we do not want any blending for this. We want to have just pure pixel data. So we're turning off blending. And then we're going to say picking texture.enable writing. Then we're going to say GL viewport, 3840 by 2160, or whatever the size you're using for your picking texture is. We want to make sure the viewport so that it draws to the whole texture. This is important too. If you don't do this, then it won't draw to the whole texture. Then we'll say GL clear color, 0.0f, 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 0.0f. So zeros all around. And then we'll say GL clear. And we want to clear the color buffer bit. And we also want to clear the depth buffer bit. Although, once again, I don't think the depth buffer bit really matters. Then we're going to have to implement a new function, which I'm going to say is called bind shader on our renderer. And we're going to take in a picking shader. And we'll take a look at why we do this in a minute too. And then we're going to say current scene.render. And picking texture.disable writing. And that should be it. Then we just want to make sure we re-enable GL blend. That way, when our actual game goes to use the blending, it can use it again. So we disabled it. We want to make sure we enable it again to restore state as it was. And then we do the second render pass, and that's all good. Now, what the heck is this render bind shader? Well, we want to make sure that we're actually shading correctly. We need to use a custom shader. And so it's a pain, the way we're doing it right now, to try and change it out. Because we're using this render batch method, right? Where each render batch basically just has its own shader. Technically, if we wanted to change this, we would have to basically change this so that every single render batch is duplicated, and that's not good. So to get around this, basically, we know that a render batch will be using one shader, right? So we don't really need to store a reference to that shader in here at all. What we can do instead is store a reference to whatever shader we're currently using inside of here. And so what we'll do is we'll say private static shader, and then we'll just say current shader. And so this will be basically a global object that is like, this is the global state of the game right now. We're using this shader right now. And so then what we can do is we can go down here and just say public void bind shader, shader, and then we'll just say current shader equals shader. So every time this is called, we just bind it to whatever the current shader is. And then inside of here, we'll just basically just say current shader.use. And then we'll have one more method here. We'll just say public static shader get bound shader. And then we'll say return current shader. And then I'm just going to make this static as well because these should both be static. So this is sort of like our global state setting for our render. This will basically set the global state of the render. And then we end up using whatever shader that is. Now we're going to have errors in here. And that is because now it's like we don't know what this shader is. So instead of doing this, we can just say shader equals render dot get bound shader. And all of our errors magically go away, but really they're not, because if we ran this right now, we would get a completely different type of error because we never actually set with the error. So I'm going to go up into the window and literally just up here, this is once again not good technique, but it works. We're going to say default shader equals asset pool dot get shader. And I believe it's assets slash shaders slash default dot GLSL. Let's just double check on that just to be sure. So if we go, yeah, assets shaders default.glsl. And I'm actually going to remove that line too because we don't really need that. So we've got the default shader, and then I'm going to go here and say shader, picking shader equals asset pool dot get shader, and we'll make that assets slash shaders slash picking shader dot GLSL. And we'll create that in just a moment. But basically this error now goes away. And what we want to do is we use the picking shader from when we're rendering to the picking frame buffer, right? Our first render pass. But then our second render pass, we should switch back to our default shader. And so then if we go into here and we just say render.bind shader, default shader, this should make sure we switch back in time to render the correct data. And if we run our game, well, first of all, we're going to get an error because we don't know what the picking shader is. So I'm going to just switch this to default shader. So basically, it'll just do nothing right now. I mean, it will render to the frame buffer, but we don't really care about that. Oh, and we're going to get an error because we don't have this shader. So let's just comment that out, the picking shader. Now, if we run it, okay, we get everything as we should expect it, which is good. We just wanted to make sure that that's working correctly. Now, let's actually make this picking shader and see what it looks like. So I'll go down to my assets over here, wherever they are. I think they're up here. Okay, they're up actually. So we'll go to assets, shaders, and I'm going to go ahead and say new file and call this my picking shader.glsl. And I'm going to add that to whatever. And then I'm going to copy this, paste it into here. And we're going to have to make a few changes because right now this isn't actually going to work the way we want it to. But if we run it, we should still get the correct result. Everything is fine. We don't get any errors. Now let's change this so that it works correctly. What we're going to do is we're going to say layout location equals 4 and float, or actually vec3 a object, a entity ID. And so this is basically the game object ID, which we'll be passing in as a vector 3. And then we'll say out float f entity ID. So then we'll pass it through to our fragment shader so that it gets it. And then we'll just say f entity ID equals a entity ID. And then this should be a vec3, not a float. Then we can go into here and we'll say this takes in a vector 3, which is the f entity ID. So now we got all that right. And then basically we're going to go up here and we'll just say vec4 text color equals vec4 1111. We'll initialize it to 1, and then basically we'll just set it in here to whatever the texture color is. And then right down here, what we're going to say is if the texture color .a is less than 0.5, return or discard. Otherwise, we're going to say color equals vec3 f entity ID f entity ID f entity ID. What is this doing? This is basically... Oh, and this should be a float. I'm sorry, this should not be a vector 3. So our f entity ID, real quick, before we talk about what's happening, just change these all to floats because we only need to pass in one. We don't need to pass them all in. Okay, and then we can change our color output here to be a vec3 instead of vec4 since we're expecting RGB data. Okay, anyways, what does this do? This basically just says if the texture, if first of all, whatever entity we're handling has a texture, so if the texture ID is greater than 0, and if that texture's alpha is greater than or is less than 0.5, which means it's basically invisible, we're just going to discard that fragment. So that means we will get alpha appropriate ID data. So basically, if you have a picture that you attach to an image and it's a donut and it has a hole in the middle, the hole in the middle will get its data discarded, whereas every single other pixel that the donut occupies will take up its entity ID. This is how we get that cool feature where we can click in the middle of the donut and it will still recognize which object we're clicking on. Okay, but that's the picking shader. Let's go back into our window and actually use it now. So we got the picking shader, we just undid it, and then we will go right here, and instead of using the default shader, we'll use the picking shader. Then we'll test and make sure that this is right. So what we'll do is we'll say if mouse listener dot mouse button down GLFW mouse button left. So if we click the mouse button, the left mouse button, we'll just say int x equals int mouse listener dot get screen x, which is a function we don't have yet, and we'll create that in just a function in just a minute. And then we'll say mouse listener dot get screen y, and we basically just want screen coordinates. And then what we'll do is we'll say system.out.print line. What do we want to print? We want to print whether our picking texture or what our picking texture says that particular pixel is. And so we'll say read pixel xy. Okay, so we'll just print out what is the pixel's actual color there. Now let's implement these very quickly. We'll just go into the mouse listener, control click if you don't know how to do that. And then we'll go down to where we have a get ortho x because we'll just modify this a little bit to get the screen x. And this will be the screen according to the game viewport. So these will return coordinates as if it was like this top left of the game viewport is x and the bottom left of the game viewport is y. So I'm just going to copy these very quickly. And I'm not going to explain too much about how this works. We're basically doing almost exactly the same thing as we've done before, except what I'm going to say is once we do the current x times 2 minus 1, we basically just want to ensure that we get that back to a range of 0 to the screen's width. And we can do that very simply just by removing all of this. We'll just remove all of that. And then instead of multiplying by 2, subtracting by 1, what we'll do is we'll just multiply by 3840 or whatever your screen width is. These are horrible. They should not be hard-coded like this, but we're doing it for now. And then for this one, what we'll do instead of this is we'll just say times 2160. And because this is flipped, we need to do 2160.0f minus whatever this value is, and then we should be good. And then we'll just return that y. Those should give us the appropriate screen coordinates. Once again, I didn't go over that too much, but it's very similar to this. Look at the code for a little bit, and you should be able to get what's happening there. Now, if we go back into our window, let's check it out, see what happens. So if we run this, and if I minimize it, I'll click on this object. It's kind of hard to see. Okay, so it says 0 when I click it. It also says 0 there, 0, 0. Why is it saying 0? Because we're not uploading any data. I just realized that. So let's go to the render batch. Let's go here. We need to add another vertex attribute. So first we're going to say vertex size is now 10. Private final int obj id, or we'll call this entity id offset equals, and before we do that too, actually we should say private final int entity id size equals 1. And then down here we'll say the offset is just text id offset plus text id size times float.bytes, and that should give us the appropriate offset and size. So then we'll go down here. We need to enable one more attribute, and the reason we're doing this, remember, is because inside of our picking shader we say we have the entity ID coming in location 4, but right now we don't have location 4 enabled. We just have up to 3. So we'll say vertex attrib pointer 4, and then we're going to say that's the entity ID size, and that is type float, and it's not normalized, and we'll say vertex size byte, and then we'll say entity ID offset, and then that should be good. Then we'll just say GL enable vertex attrib array 4. Now that's not all we have to do. The data is not going to get uploaded magically. We have to actually upload the data. So in order to do that, we'll just go down here, and right after we load the texture ID, we'll say load entity ID. And that's simply offset plus 9. We're just going the next vertex, the next float, and then we'll just say that is the sprite.gameObject.getUID, which, if you'll remember, is the game object's unique identifier. So that's exactly what we want. Now let's run it and see what we get. All right, so if we close that and then we click on an object, 14. Awesome. 3. 20. Now I don't know if these are actually correct, but they sure seem correct to me. And that's really cool. We're clicking on an object and it's showing the correct object. Now let's do something a little bit more interesting. If I drop this guy in, and you may be able to see if I click just barely onto his pixel, we get 31. But if I click off, we get 0. Now, we don't want it to return 0 if it doesn't hit an object. We want it to return -1. And so in order to do that, it's very simple. What we'll do is, and why is it doing 0 too, real quick, before we actually do this? Why is it 0 if I don't click on an object? And that's because we're looking at this color. So if I make this 1, we're looking at the red color, and we change the clear color to 1. Then if I click onto the background, we get 1. If I change this to 0.5, we would get 0.5. We get whatever this red color is, and that's because we're just using this red color right now. And so in order to fix that, what we're going to do is we're just going to go into the render batch one more time. We're going to upload the ID +1 just because we're going to use 0 as a flag that this is an invalid object. And then we'll go back into our picking texture, and we will return integer pixels 0, and we will subtract 1. That way we get back to the appropriate ID. Now if we go in and we click the background, we get -1. But if we click an object, we get the object ID. Okay, I'm not going to go any further today because this is way long and you guys are probably itching to be done with this tutorial. But we have just implemented a picking texture, and we've just implemented picking, pixel perfect picking. So our game engine, we can now click on objects and know which object we're clicking. We know the object ID. This is great because now we can click on it and we can show its properties in the properties panel. This is amazing, guys. We are one step closer to a real kind of working game engine, okay? So that's it for this tutorial. I hope you liked it. If you did, please hit like and subscribe. And I have no idea what we're doing in the next tutorial, probably finishing this. So thanks, guys. I'll see you.